Allotropes of sulfur. Sulfur appears in the 16th group on the periodic table. The Earth's surface contains 0.17% sulfur. Sulfur forms numerous allotropes, of which the yellow rhombic and monoclinic forms are the most important. Rhombic sulfur, alpha sulfur. It is crystalline in nature and has an octahedral structure. Rhombic sulfur crystals are formed on evaporating the solution of rolled sulfur in CS2. Its melting point is 385.8 Kelvin and specific gravity is 2.06. It is yellow in color. It is insoluble in water but dissolves to some extent in benzene, alcohol, and ether. Monoclinic sulfur, beta sulfur. This form of sulfur is prepared by melting rhombic sulfur in a dish and cooling till the crust is formed. 2 holes are made in the crust and the remaining liquid poured out. On removing the crust, colorless needle-shaped crystals of beta sulfur are formed. 369 Kelvin is the transition temperature as both allotropes of sulfur are stable at this temperature. Both rhombic and monoclinic sulfur have S8 molecules. These S8 molecules are packed to give different crystal structures. S6 and S8, structure of rhombic sulfur. The S8 ring in both the forms is puckered and has a crown shape. Like O2, this is also paramagnetic. Uses of sulfur. Sulfur is used in the vulcanization of rubber. Many of its compounds are used as fertilizers in agriculture. Many bleaching reagents are made of sulfur. Chemical properties. Many metals and nonmetals react with sulfur under fixed conditions. Sulfur burns in air with a bright blue light. Sulfur dioxide and trace amounts of sulfur trioxides are formed. At high temperatures, it reacts with hydrogen to form hydrogen sulfide. Sulfur vapors react with hot coke to form carbon disulfide liquid. Oxoacids of sulfur. Oxoacids are acids containing oxygen. Sulfur forms a number of oxoacids such as H2SO3, H2SO4, etc. When sulfur combines with oxygen in sulfur oxoacids, it shows a tetrahedral structure. Most sulfur oxoacids contain a S double bond O and a S single bond OH bond. Sulfuric acid, H2SO4. H2SO4 is a diprotic acid. It ionizes to give 2 protons. In sulfuric acid, the remaining 2 oxygens form pi bonds with sulfur. Therefore, sulfuric acid exhibits tetrahedral geometry. The O double bond S double bond O bond angle is greater than the OH single bond S single bond OH bond angle. Sulfuric acid, H2SO3. Sulfuric acid is a diprotic acid. It ionizes to give 2 protons. In sulfuric acid, sulfur is attached to 2 single bond OH groups while 1 oxygen forms a pi bonds with sulfur. It can be prepared by dissolving sulfur oxide in water. Peroxodisulfuric acid, H2S2O8. Peroxodisulfuric acid contains sulfur in +6 oxidation state. Therefore, it is a strong oxidizing agent and extremely explosive in nature. It is also called Marshall acid. It contains a peroxide linkage between the 2 sulfur atoms. Apart from the peroxide linkage, each sulfur is attached to 1 OH group and 2 oxygens. Hydrogen peroxide reacts with chlorosulfuric acid to form peroxodisulfuric acid. 2ClSO3H plus H2O2 gives rise to H2S2O8 plus 2HCl. Sulfuric acid, H2SO4. Sulfuric acid is manufactured by the contact process which involves 3 steps. Stage 1. Manufacture of sulfur dioxide. Burning of sulfur in excess air generates SO2. The product mixes with oxygen and becomes useful in the next step. S plus O2 gives rise to SO2. Stage 2. Manufacture of sulfur trioxide. At 400 to 450 degrees centigrade, oxygen reacts with sulfur dioxide in 1:1 ratio in the presence of V2O5 catalyst at 1 to 2 atm pressure to give rise to sulfur trioxide. SO2 plus O2 gives rise to SO3. Stage 3. Manufacture of concentrated sulfuric acid. Absorption of SO3 in H2SO4 to give oleum. SO3 plus H2SO4 gives rise to H2S2O7. Dilution of oleum with water gives H2SO4 of the desired concentration. H2S2O7 plus H2O gives rise to 2H2SO4. The reaction is exothermic reversible and the forward reaction leads to a decrease in volume. Therefore, low temperature and high pressure are the favorable conditions for maximum yield. The sulfuric acid obtained by contact process is 96 to 98% pure. Physical properties. It is a colorless or slightly yellowish dense liquid. It has a specific gravity of 1.84, a boiling point of 337 degrees centigrade and 10 degrees centigrade melting point. Concentrated sulfuric acid is 98% in water, which is its stable form. It dissolves in water to give a lot of heat. Chemical properties. It has a low volatility, strong acidic nature, high solubility in water, and the strength to oxidize, which dictate its chemical reactivity. H2SO4 plus H2O gives rise to H3O plus HSO4 minus. HSO4 minus plus H2O gives rise to H3O plus SO4 2 minus. Ka1 is very high. Ka1 is greater than 10. Ka1 is equal to 1.2 into 10 to the power of minus 2. Uses of sulfuric acid. It is used in fertilizers and in the production of iron and steel. It is used in chemical industries. It is also used in petroleum purification and the production of phosphoric acid. In the production of nylon, it acts as a catalyst for the conversion of cyclohexanone oxygen to hexaprolactam. It is an electrolyte in batteries and in the production of ammonium sulfate. Sulfur dioxide. The chemical formula of this compound is SO2. It is of low concentration in the Earth's atmosphere. It can be found in volcanoes and in industrial pollution. SO2 is the chemical formula of sulfur dioxide. It is also called sulfurous acid. Anhydride. Sulfur anhydride and sulfur oxide. Structure of sulfur dioxide. It is a bent atom of 1.5 bond angle. Its resonance structure is due to valence bond stability formed using s and p orbitals. Preparation. In the laboratory, it is readily generated by treating a metal sulfide or metal disulfide with dilute acid gives sulfur dioxide. For example, dilute sulfuric acid reacts with sodium disulfide to give SO2. Na2SO3 plus H2SO4 gives rise to Na2SO4 plus H2O plus SO2. Industrially, it is produced as a byproduct of the roasting of sulfide ores. 4FeS2 plus 11O2 gives rise to 2Fe2O3 plus 8SO2. Sulfur dioxide is formed together with a little sulfur trioxide when sulfur is burned in air or oxygen. SO2 plus O2 gives rise to SO3. Physical properties. Sulfur dioxide is a colorless gas with pungent smell that boils at 263 Kelvin. It liquefies at room temperature under a pressure of 2 atmospheres. It completely dissolves in water. Chemical properties of sulfur dioxide. It is an acidic oxide. It splits in water to form sulfuric acid. SO2 plus H2O gives rise to H2SO3. It reacts readily with sodium hydroxide solution forming sodium sulfide. 2NaOH plus SO2 gives rise to Na2SO3 plus H2O. In its reaction with water and alkalis, the behavior of sulfur dioxide is very similar to that of carbon dioxide. Sulfur dioxide reacts with chlorine in the presence of charcoal, which acts as a catalyst to give sulfuryl chloride. SO2 plus Cl2 gives rise to SO2Cl2. It is oxidized to sulfur trioxide by oxygen in the presence of vanadium oxide catalyst. 2SO2 plus O2 gives rise to 2SO3. When moist, sulfur dioxide behaves as a reducing agent. For example, it converts ferric salts to ferrous salts and halogens to halogen acids. 2Fe3 plus SO2 plus 2H2O gives rise to 2Fe2 plus SO42 minus plus 4H plus. X2 plus SO2 plus 2H2O gives rise to SO42 minus plus 2X minus plus 4H plus. X is equal to halogen. Sulfur dioxide uses. It is used as a preservative in food industry. It is used as a liquid reagent in laboratories. It is a coolant in storage plants. It is used as a bleaching agent to remove excess chlorine, and also as a pesticide. Liquid SO2 is a solvent to dissolve many carbon-based chemicals and also in the purification of sugar and petroleum.